Hi everyone, and welcome back to Beginning Algebra. So, it's been a few weeks, but trying to get through it. The last time we met, I guess you can say we met. The last time we were looking at this stuff, we were doing prime factorizations of numbers. So I hadn't really explained to you why the heck this is in the packet on fractions, okay? So let's scroll back up. We're in packet 5 on fractions. We're talking about prime numbers and composite numbers. Remember, a prime number is a number whose only factors are 1 and itself, where a factor are the things that you can divide it by. Okay, so they're also sometimes called the divisors. So when you do a prime factorization, what you do is you rewrite the number as a product of only prime numbers. Okay, so we were doing that, and we learned some different divisibility tests, which makes it a little easier to do these prime factorizations. But remember, there's no shame in just using your calculator if you got to do it. Just look at the list of prime numbers and see which one is divisible by, and you can break it down in this like tree-like structure. Okay, so why were we doing that? The reason we were doing that is because it's going to help us with simplifying fractions, which are still not quite there yet, because we still need to talk about just some general introduction info about fractions. Okay, so that was a review of what we did last time. Remember, you can just go watch the video if you missed it. So all of the class content is available at that link that's listed in the top right hand corner. You can scan that QR code if you want, but you can see links to the videos and download all the packets. You can see what's coming up. All of it's in there. Also, all of it's free. You don't have to it's for anybody. You don't have to be in my class or anything to get it. So let's talk about fractions. So a fraction is just a quotient or division of two numbers. So when you're talking about a fraction, the numerator is the number on top, and the denominator is the number on the bottom. Okay, and then the thing that divides them, the little line between them, is called the fraction bar. That's probably the last time you will ever hear me say the word fraction bar. Well, I already lied to you because I just said it again, but it's not something you really reference a lot. Even though I know it's called the fraction bar, even if I want to talk about it, I might just call it the line or the bar or whatever. But the important word in that little diagram is numerator and denominator. Okay? So a fraction, while it does represent a division, it also refers to a part of a whole. Okay, so for example, that fraction 5/6 refers to 5/6 of the circle. Okay, so what that means is if you had a circle and you broke it into 6 pieces, 5/6 would be taking 5 of those. Okay, so when you're dealing with fractions, there's different forms that they can take. A proper fraction is a fraction whose numerator is less than its denominator. So 5/6 was an example. 7/8. Well, let me do a different one. 7/12. I don't want to just keep doing ones where they're only one off. 1/3. 2/9. Any number where the number on the top is smaller than the number on the bottom. Okay. An improper fraction is a number whose numerator is bigger than its denominator. So something like 9 halves. I wrote that too weird. think there's like a hotkey on this. Ooh, I didn't know that was there. I think I might have an eraser too. Sorry, I'm playing with my tablet pen. Okay, so 9 halves, 5/3, I don't know, just anything where the number on the top is bigger than the number on the bottom. Now, improper fraction has, like, the word improper has almost like this negative connotation to it, but they're not bad. In fact, they're actually a much more manageable format of fractions that are like that. Improper fractions and mixed numbers are two ways of writing fractions that represent like a whole and then a fraction, or some amount of wholes in a fraction. So it's like where the fractions that are proper, they're all smaller than one full thing. Fractions that are improper, they're all like one full thing plus some. So maybe it's like 2 full things, or like 5 full things, and like a half of a thing. But it's always like more than one. Okay. Mixed numbers are the same thing. They're always more than one. And while mixed numbers are a little easier to understand because they are something like 4.5 or 1 2/3, those are easier for us conceptually to think about. Okay, I've got 4.5 apples. That's easier to think about than 9 half apples, which is, so those two things are actually equal to each other. Or I've got 1 2/3 of a pie versus I've got 5/3 of a pie. You know, it's a little harder to think about. So while improper fractions are maybe a little harder for us to visualize and think about, they actually are easier to work with mathematically. Okay, so when we start doing like multiplication and division on these things, we're usually going to rewrite them from a mixed number to an improper fraction. Excuse me. So when you're writing fractions, like I've been writing them with this horizontal fraction bar, and I've done exactly what I said not to do here. I am breaking my own rule. So I'm going to fix these. 5/6, 7/12, 1/3, 2/9, 1/3, 2/9. Okay. So what was this, 1/2? I'm going to leave the other ones the way. It's fine. It doesn't really matter. So when you write them using so it says to write them using the horizontal fraction bar, not the diagonal bar. Now, it doesn't really matter. The reason I put that is because because I said that's super weird. Math is super easier. To do the math on it is way easier if you write it with without the diagonal. So math is easier horizontally. Like way easier. So it really doesn't matter if you use the diagonal bar. It's not gonna like cause any problems if you write 4.5. And in fact, 4.5 it's a little easier to see when it's written with the diagonal thing. But it's just gonna be easier if you write them with the horizontal bar, because when you start doing this more complicated math with them, it'll just be good to be in that habit. Okay, so let's talk about the concept of equivalent fractions. And this concept of equivalent fractions is what is going to get us through pretty much all arithmetic with fractions. Okay, the fact that there are these things called equivalent fractions is like the bread and butter of fraction arithmetic. Okay, so when you have a fraction, the way it works is the denominator represents the total number of parts. Okay, so let's actually look back up at this one, our first example. I had this circle, and I cut it into 6 total pieces. Each of those pieces, and forgive me because this word is hard to say, each of those pieces is called a sixth. So this is a sixth. Okay, so this is a sixth, or you can say 1/6, right? So it's 1/6. This is also 1/6. The way you write 1/6 is 1/6. Okay? So if each one of them is 1/6, we have 1/6, 2/6, 3/6, 4/6, 5/6. We have 5 of them. We have 5 of these things called sixths. I really should use a better one that pluralizes a little better. So we have 5 of them. So that's why we have 5 of this thing called sixths. So when it comes to a whole thing, like this whole circle, I can cut it into as many pieces as I want. And each one of these pieces needs to be of equal size. Okay, so this one, there's 1, 2, 3, 4, 5, so there's 10 of these. So each one of these is called a tenth. Okay, so the denominator in this example would be 10. There are 10 total pieces that this circle has been divided into. Now, the shaded version, the shaded part represents 5 of them. There are 5 of these pieces called tenths. Okay, so remember, each one is called a tenth or a 1/10, and I've got 5 of them, so I've got 5 tenths. Now, I could have broken my circle, and if you like thinking about it as a pizza pie, because pizza pie is a nice way to think about fractions. If you got this pizza, you can cut it into 10 pieces, and then you can give 5, let's say you eat 5 pieces, okay? Say, yeah, I ate 5 pieces of the pizza. Now, if you don't know how big those pieces are, it's not really helpful for you. But if you say I ate 5 tenths of the pizza, that lets you know how much of the pizza you ate. Now, the next one, you can see it's written, it's split into 6 pieces, so there would be sixth, so each one of those would be a sixth. So here we have 3 of them, so we have 3/6. And then the next one is divided by 2. So we wouldn't say seconds, we would say half. So in this case, we have 1/2. So notice in all 3 of those pictures, the red part looks the same. If you squint and you can't see the black lines anymore, it's the same amount of red. Okay, so whether you ate 5 pieces of a pizza that was cut into 10, or you ate 1 piece of a pizza that was just cut in half, you still ate the same amount of pizza, right? So all of those fractions are equivalent. They all represent the same portion of the whole. And like I said, this whole equivalent fraction thing is super important because it's going to allow us to do various arithmetics with it, and it's going to allow us to do what is known as simplification, where you write the fraction in a way that using the smallest numbers possible. Okay, so let's look at how do we use this concept of equivalent fractions. So the thing about equivalent fractions is, let's look at this one here. So this is 1/2. So to get from 1/2 to 3/6, we cut the pizza so that we had 4 more pieces. But that's like not a very helpful thing for us in this context. The thing that's important is to think about the numbers here. What's the relationship between these two numbers? What's the relationship between these two? And you'll notice that to get from 2 to 6, you multiply by 3. And to get from 1 to 3, you multiply by 3. Okay, so to get between those two, you multiplied the numerator and the denominator by 3. Now, let's do the same to get to the 5. It's not as easy to do it from 6 to 10, but we can do it this direction. From 2 to 10, to get from 2 to 10, we multiplied by 5. So to get to the numerator, we also multiplied by 5. So that's not a coincidence. Whenever you multiply the numerator and denominator of a fraction by the exact same number, you are creating what is known as an equivalent fraction. So when you multiply by the numerator and denominator by the same thing, essentially what you're doing is multiplying by the number 1. So if I do a over b times c, a times c over b times c, this is really the same thing as, and we'll talk about this more when we do fractions, it's the same thing as a over b times c over c. And c over c, remember, anything divided by itself is just 1. So this is the same thing as just taking this and multiplying it by 1. Okay, so let's try to rewrite. I don't know why there's so much space here. Oh, probably to do the math. Okay, let's do the math. I was wondering why I had the diagram and not the math anyways. So if we want to write 5 over 8, or 5/8, as a fraction with a denominator of 16. So to do that, I'm going to need to multiply 5 over 8 by something over something, and that something needs to be the same thing. So let's figure out first, well, what does 8 need to be multiplied by to get to 16? 2, right? And actually, let me do this different color. So if I multiply the denominator by 2, I need to also multiply the numerator by 2 to maintain equivalent fractions. Okay, so you can multiply the numerator and denominator by whatever the heck you want, as long as you multiply both of them, the numerator and denominator, by that thing. So that gives us 10 over 16. So 10/16 is equivalent to 5/8. Let's get a highlighter. So 1, 2, 3, 4, 5. Okay. Can't draw. Okay, let's see if I can try this again. And now I'm going to sneeze too, so I can't color today. So that's 5/8. Where's the highlighters? I don't want the, oh, these are the highlighters. I don't know why my highlighters aren't, here we go. Yeah, that's what I'm talking about. Okay. I don't know why my highlighters aren't saved as like my quick drawing things anymore. Okay, so that was 5 of these things called 8s. So these long strips were called 8s. Well, now these little bars here are called 16ths. So to highlight the same amount of area, I need to do 2 of these. Okay. So notice, by doing times 2, what that's really saying is what I did with each one of these is for every one, I made them 2. Okay, so I multiplied these 5, I multiplied them by 2 by making them into 2, took 1, made it 2. I did that for those 5, and then I also did it for all 8. Okay, so now let's take 7/10 and set it equal to something with a denominator of 30. So I'm going to use the same little template here where I say, okay, well, I got to multiply the numerator and denominator by something. So what is that something? So 10 to get to 30 is 3. So 10 times 3, and 7 times 3 is 21. So 21/30ths. So I don't know why I don't have a... Sorry, I just keep complaining about my pens. All right, here we go. So 7/10, that is this portion right here. So these long bars are called tenths. Now, I've got 7 of those tenths. Now, to multiply the numerator by 3, that means for each one of these, divided into thirds. Or, I'm sorry, not divided into thirds, but to take each one of those bars and make it into 3 of them. So for 1, I need 3. And I also needed to do it for all 10 of the pieces. So I am going to highlight the same equivalent piece. And you'll notice all I did was just kind of cut them into 3. Okay? So it also, we'll do a little bit more of this with like mathematics, but multiplication is like you go from going in one direction to 2 directions. That's how you do the multiplication. So that you can see, like, to get the 3, that just means to draw 3 pieces going in the opposite direction. But sorry, I digress, and it wasn't really important. So, and I probably wasn't making much sense anyways. So where's my good pen? Okay, so what we were just doing is we were taking these fractions, and we were giving them bigger denominators. Essentially what we were doing is unsimplifying them. Like this 7/10, these are nice clean bars, there's 7 of them. This looks like a lot less simple, right? There's way more of these things. So a simplified fraction is a fraction whose lowest, it's also called lowest terms, is when the numerator and denominator have no common factors. Okay, so this fraction here, 21/30ths, was simplified to 7/10. So some examples of simplified fractions are 7/10. Let me 7/10. I don't know, 2/3. 3/2. An improper fraction is still considered simplified if the numerator and denominator have no common factors. 9/13. So the goal with a lot of this stuff is to first simplify fractions. Okay, so if you have a fraction, if your answer is a fraction, you always want to write it in simplest terms. Okay, so every fraction, you never want to write your answer as 21/30 unless you're specifically being asked for something like this. If the answer that you get ends up being 21/30, you need to then simplify it. So how do we do that? This is where that prime factorization stuff that comes in. Okay, you want to rewrite your numerator and denominator as their prime factorization, and then remember, whenever you have the numerator and denominator being multiplied by the same thing, that was essentially being multiplied by 1, right? So that means by having those there, you're not really doing anything to the fraction, you're just adding clutter to it. So you can take those numbers, if it's in the numerator and denominator, and you can cross them out. So we're going to just go in the opposite direction of what we've been doing. Okay, so like this here, when we multiplied by the numerator and denominator by 3, we were just adding complication to it. But if we found that we could write 21/30 like this, we'd say, hey, these 3's, this extra stuff, let's cross them out. Okay, let's just try it. So what you want to do is write the numerator and denominator in their prime factorization. Okay, so I'm gonna do, it's gonna take a little bit of work. Let me zoom in a little bit too, because I can't write this small. This pen is fatter than I want it to be, but I don't know where my skinnier pen is. I only have a skinnier one of the black one, or the red one for some reason. Okay, so 30 is 3 times 10, right? 3. Oof. Gosh, please tell me there's a skinnier black one somewhere. Okay, I think I found it. How can I add it to? Add to favorite pens. I did not do anything. It's here. How do I add it to the quick access toolbar? Oh my gosh, it's so much. Okay, is this it? That still feels too fat. Cause see this one. Oh, I guess it's good. Sorry, talking to myself. Okay, so 30 over 84. So I know 30 is 3 times 10. And I know 10. So I would write 10 here. So I can do 3 times 10 and then I can keep going, you know. And then I know 10 is 2 times 5. Okay. So all 3 of those numbers are prime. So we're good. 84. This one's a little more complicated. So I know it's 4 times 21, right? And 4 is not prime, but 4 is 2 times 2, and 21 is 3 times 7. Okay, so let me do some color coding here. This, I made that, and then this one I turned into that, and then, oh, we don't have any more colors, no! Here we go. That one became that. Okay, so I just broke it down further. So now I can do my favorite part, which is say if any number is in the numerator and in the denominator, I can just cross them out. So I see a 3 and I see a 2, and I can only cross out one set of 2's because to cross out that other 2, there would need to be another 2 here. So what I'm left with is just a 5 in the top and a 2 and a 7 in the bottom. So whatever's left over, you're going to multiply together. So this is going to be 5 over 14, so 5/14. Okay, so let's try this again. So 140 over 210. So there's actually a nice trick with these. You don't have to cross out only prime numbers, okay? Like if you notice a number before you get to the prime factorization, you can go ahead and cross it out. So what some people will do with ones like 140 over 210 is they'll realize, oh, those are both divisible by 10. So maybe they'll write 140, gosh, I got my dumb fat pen again. So maybe they'll write like 140 over, let me try this again. I guess I'm going to just have to use the stupid fat pen. Okay, 14 times 10, and then 21 times 10, and they'll cross them out, right? But you could also have done this. Could have been a little slick about it. You could have said, well, 140 and 210. Okay, I'm going to cross out those little zeros there, and I just have 14 over 21. So you could have also done that. Okay, so let me scooch this over here, because it's kind of like a side note. Okay, so this is kind of like just a little trick. So we got our 140, or I'm sorry, we've got 14 over 21. So let's break up the 14 and the 21. So I know 14 is 2 times 7. And I know 21 is 3 times 7. And how about that? We got some 7s. Let's cross those out. And the only thing we're left with is a 2 and a 3. Okay. So let's try the next one. 42. Well, I know it's definitely divisible by 2. It's 2 times 21. So you can write it step by step like this. And then what I like to do is I like to just keep going. on the numerator until I'm done with it, until I get it to all prime numbers. 2 times 21, and then 21 is 3 times 7. Okay, 126, that one's a little harder. It's definitely 2 times something. 126, 2 goes into 12 6 times, and then it goes into 6 3 times, so it's 2 times 63. Excuse me. Okay, well, I know 63 is divisible by 3. It's 3 times something, so 3 times 21. Okay, now here, if I had, you know, not taken the other one all the way to the prime factorization, maybe I would have seen that the 21 was there and I would have crossed it out. But I really like going all the way down to the full prime, so I'm just going to rewrite this numerator. I don't need to do anything else to it. So 3 times 3, and now I'm going to break that 21 up. Break that 21 into 3 times 7. Now I do recommend that you take it all the way down, take it all the way across, rewrite everything, even if like the numerator didn't change, rewrite it. It just makes your steps very clear. It makes it very obvious what you're doing, makes it really readable. Okay, and it makes it easier for you when you go back and you look at your notes to figure out what the heck you were doing. All right, so what can I cross out? Well, cross those 7s out and cross those 3s out. Looks like the only thing I'm left with in the numerator is a 2, and the only thing I'm left with in the denominator are a 3 and a 3. So it's 2 ninths. Well, that's a lot smaller. Okay, so the thing about this is, yeah, this is this fraction looks way smaller than this one, right? But remember, they're equivalent, so they're the exact same size. And in fact, these pieces that are called ninths are actually a lot bigger than these ones that are called 1/26. The bigger the denominator, the smaller the pieces. Those were like slivers. If that was a pizza, 126th slice pizza would be super small. You wouldn't even get any food for that. So let's zoom back out. So this whole concept of simplifying fractions is super important. Whenever you write a fraction, you always want to write it in its simplest form. Now, fractions, remember I said mixed fractions, while they make more sense to us, it's easier for me to understand 4½ apples than it is for me to understand 9½ apples. It's much easier to do math on the 9½ than it is to do math on the 4½. Okay? So whenever you have a mixed fraction, you're going to need to convert it to an improper fraction. Now the way you do that is, so you take the denominator and multiply it by the whole number, and then add it to the numerator. So you do denominator times the whole part, and then add it to the numerator. So it's kind of like this swirly, 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 swirly thing. Okay? Even though it's just one swirl. So to do this, to convert 5 3/8 to an improper fraction, and let's zoom back in again. I'm going to take the 8 and I'm going to multiply it by 5, and then I'm going to take that and add it to 3. So the denominator stays the same. Okay. I'm going to take 5 times, or 8 times 5. So 8 times 5, and then plus 3. Okay. So the denominator, nothing ever changed with that. 8 times 5 is 40, plus 3 is 43. Maybe I should just write 40, maybe I should just do that extra step. I'll just leave it that way. Okay, so while 5 3/8 is easier to comprehend, 43/8 is going to be easier to do math on, and it just represents the same thing. Okay, let's do it with 6 3/10. So I'm going to multiply and then add. So the denominator stays the same, nothing happens to that, and then I do 10 times 6 plus 3, so 63 tenths. Okay? So maybe you need to go the other way. I keep talking about how important it is to be able to go to the improper fraction form because it's going to be easier to do math on. But like, what if you just need to explain to somebody, you know, I have 6 3/10 of a pizzas. You don't want to tell them 63 tenths. I mean, maybe that, you know, I've got 63 slices and each one is a tenth. You know, that makes sense, I guess. But maybe that does make more sense to you. But they probably want to know, I've got 6 pizzas and then one with 3 slices where each pizza was cut into 10. That makes more sense to most people. Okay, so maybe you do need to go in the other way. So the way you do it is you take the fraction, and remember 19 over 3 represents a division. That represents 19 divided by 3. So you perform the division, so essentially you kick this thing over and you put the 19 on its side, 3 divided by 19, and however many times 3 goes into 19, that's going to be your whole part. And then the remainder, whatever the remainder is going to be whatever the numerator is on the fraction. Okay, so let's just look at an example of this. So we would rewrite this as 5 going into 37. So how many times does 5 go into 37? So 5 times 7 is 35, right? Oops, don't want to write 35 there. Yeah, because, yeah, I don't know why my brain didn't want to believe that for a second. So 5 times 7 is 35. So 5 times 7, 35. Put my 2 there. So this right here is my remainder. Okay, let me scooch this. So 7R2. Oh, golly, I hate this fat pen. R2. Okay. So I know y'all can't see what's going on, but behind where it says Beginning Algebra, I have all my pens, and the one in the quick bar is not the pen I wanted, it's the fat one. So anyways, so the 7 is my whole part. The remainder is my numerator, and then the denominator stays the same. Okay, let's try it again. So I'm going to do 2 into 9. 2 goes into 9 4 times, because 2 times 4 is 8. So when I perform that subtraction, I get 1. So this is my remainder, R1. So this is equal to, this part, remember, is the whole part. Okay, and then the remainder is the numerator. Oops, I did the wrong one. I did the one from the previous example. So the remainder was 1 here, and then the denominator is the same as the previous one. Okay, let me get a different color here. Okay. Oh, actually, let me get it from over here. Let's be more clever about this. Okay, so that's where you get those numbers from. So the number that ends up at the top, the whole part, however many times the number goes into the denominator, that is your whole part, and then your remainder is the numerator on your new fraction. Okay, so Now we can get to the fun part, which is doing math on these things. So how do you multiply fractions? Not doing math, I guess I should say doing arithmetic. We've been doing math this whole time. How do you multiply fractions? So remember when we were doing those percent problems, and I kept talking about the word of, 20% of 30. And I said the of always was going to represent a multiplication. Well, that's true in these other instances as well. Of means multiplication. So if you have 1/2 of 10, that means do 1/2 times 10. So half of 10 is 5. So how do I do 1/2 times 10? Okay, so that's what we're going to talk about. So this, if you wanted to do 1/2 times 1/3, that means take 1/2 and cut it in 2/3, and then you just are going to get the one of those, and it's 1/6. So how do you multiply fractions? It seems kind of complicated, but it's really not that bad. When you multiply fractions, you just multiply numerator by numerator, denominator by denominator. That's all you got to do. Okay? So if I want to perform 5/12 times 3/7, all I got to do is 5 times 3 over 12 times 7. That's it. That's all I got to do. A lot of students see this and they start remembering this thing called like cross multiplication, and they get really excited and they start multiplying across 5 times 7 and 3 times 12. Cross multiplication, yes, it is a thing, and yes, you may have a memory of it buried in there somewhere, but it is not how you do multiplication. Cross multiplication is for solving proportion problems, which we'll do way later, okay? So don't do any cross multiplication. You multiply this way. Top by top, bottom by bottom, okay? So remember I said whenever you give, so I can go ahead and say this is 15. If I wanted to, I could be like, oh, okay, this is 15 over, what is that, 70 plus 14, so 84. I can say that if I wanted to. And I just did, right? But remember I said fractions always need to be represented in their simplified form. So I could do 15 over 84, but then I'm going to have to break it up into all of its little pieces again so I could simplify it. So I'm just like making more work for myself if I make it 15 over 84, because now I got to break it up again. Okay? So instead of breaking it up, instead of going this way, I'm not going to do that. I'm going to just keep going this way. I've already got 5 times 3 broken up. That's pretty cool. Those are already prime numbers. But 12 is not prime. 7 is. 12 is 4 times 3. Now, I could keep going, and I can write 4 as 2 times 2 if I wanted to, but I know there's no 2's in the numerator. And that's all I really care about, is are there numbers in the numerator that are also in the denominator? There's no 2's in the numerator, so I don't even need to worry about breaking up that 4. I could write it if I wanted to, but I'm not going to. I do know, however, that these 3's will cross out from each other. So now, I can write 5 over 4 times 7. So 5 over 28. Yeah, so don't even worry about writing the 15 over 84. Because you would have just you would have wasted your time by doing that. You would have made more work for yourself. Because then you would have had to divide both of them by 3. Okay? Alright, let's try 1/6 times 1/6. It's 1 times 1 over 6 times 6. Well, that's not too bad. Whenever there's a 1 in the top, you know you don't have to simplify anything. And that's really easy. Well, it's much easier for you. You can rejoice and realize that you don't have to do any more work. So 1/36. Okay. Now, another thing you could do before you start multiplying your fractions is you can go ahead and simplify them before you multiply them. And that would save you a little bit of time. I'm not going to do it here, but if I wanted to, I could have. I could have simplified that to 3 times 1/2. But I'm just going to leave it like this. Well, maybe I'll do it both ways just so you can see. So it's 3 times 10. Oh, sorry, let me not skip anything. So it's 30 times 4 over 10 times 8. All right, so let's break these guys up. So 30 is 3 times 10, and then 10 I'm just going to leave like that because I already got that 10 up there, right? And then I'm going to leave the 4 alone too. 2 times 4. So I broke this up into that, and then this up into that. So if you want to keep going, and I recommend if this is kind of uncomfortable for you that you do keep going, okay? Because I could go ahead and cross out my 10s and cross out my 4s, but if you want to keep going, I keep grabbing the wrong pen, you can say this is 3 times 2 times 5 times 2 times 2, and then 2 times 5 times 2 times 2 times 2. Okay? And then you can, this is kind of fun because you can go to town and just start crossing off lots of twosies. 1, 2, 2, 2, another 2, and 5. And then all you're left with is 3 over 2. So I could have started crossing here. Okay, so I could have done it there if I wanted to. Yeah, so I could have done, let me just, because this is the way I was going to do it. I want to show you just in case you. So you could have gone like this. Oh, wrong pen again. I am like, sorry if I'm being kind of spazzy today. I'm feeling a little spazzy today. All right. Cross out my 4s, cross out my 10s. 3 over 2. Okay. So let's do some more. These are fun. Okay. So I've got 26 times 17 over 51 times 13. Nice thing about 17 and 13 is they are prime numbers, so I don't need to worry about simplifying those two guys. But I do need to simplify 26. So 26 is 2 times 13, right? So 2 times 13, and then can't forget our 17 there. 51, I have no idea what the heck goes into 51. 3 does, because 5 plus 1 is 6, and 6 is divisible by it. But I don't know what it is. I'm going to guess, based on this problem, that, and I know me, I'm going to guess it's probably 3 times 17, but let's just check our calculators and see. 51 divided by 3, how about that? Yeah. So it is 3 times 17 times 13. Exciting! Cross those guys out, cross those out, and I'm left with 2 over 3. Okay, so how the heck do you do this? 5 over 64 times 2. Well, when you see something like this, a fraction times a whole number, you want to rewrite that whole number as a fraction. It'll make the multiplication a lot easier for you. So if I rewrite this as 5 over 64 times, now a fraction, a whole number, is just, to rewrite a whole number as a fraction, it's just that number over 1. So 2 over 1. So this is the same thing as 5 times 2 over 64. Excuse me. All right. Well, I know 64 is divisible by 2. 5 times 2. So if I want to start breaking it up, 5 times 2 is 24. 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 5 times 2 64 is 2 times 32. And I can go ahead and cross those out. I know there's no 5s in 32, so I don't have to go any further and get 5/32. Okay. If you can multiply fractions, you can divide them. Give me just a second. I want to see if I show you all how to do this in the calculator. Okay, I don't, so I'm going to do it after division. And I'm going to write a note to myself here so that I don't forget, because it might not be until next time. So note to self, show how to in calculator. So I will show you how to do it in the calculator. Maybe I do it at the very end. Feels like I do it at some point. Nope, I just willfully don't show you. And I mean, maybe I have my reasons for that. I know when I teach this class, I don't let students use their calculators on test for this because I want them to be able to do it. Well, I let them use little tiny calculators that only can do addition and subtraction. But I will show you how to do it on a calculator, just so you can see. But I recommend you practice doing it without the fancy calculator like this one. So, anyways, if you can multiply fractions, you can divide fractions, because there's only one little thing that's different about it. When you want to multiply a fraction, when you want to divide a fraction, what you do is essentially rewrite it as a multiplication. And the way you do that is by doing what is known as multiplying by the reciprocal. If you have a over b divided by c over d, you rewrite it as a over b times, so the reciprocal of this is when you flip it. So the reciprocal is d over c. Okay, so if I want to multiply or do any kind of division, the first thing I need to do is figure out what the reciprocal of something is. So two fractions are considered reciprocals of each other if their product is equal to 1. So 0 does not have a reciprocal. Doesn't make any sense. Okay, and that's because you can't, essentially because you can't do division by 0. Okay, so, and also because you can't multiply anything by 0 and get 1. So the definition is that their products are 1, and everything times 0 is 0, so it physically can't happen. Okay, so if I want to find the reciprocals of each of these numbers, I just flip them. So this is the same thing as 3 over 1 or 3. The reciprocal of 12 is, so 12 is like 12 over 1, right? So that's the same thing as 1. So the reciprocal would be 12. The reciprocal of 2/5 would be 2/15 would be 15 halves. So if I want to perform a division, I need to find the reciprocal of the second one and rewrite it as a multiplication. So instead of doing 1/3 divided by 5/6, I'm going to do 1/3 times 6 over 5. All right. So I'm going to rewrite that as 1 times 6, 3 times 5. Well, 1 times 6 is just 6. I don't need to even do anything with that. But I can rewrite 6 as 2 times 3, right? 3 times 5. Cross those bad boys out, and I'm left with 2 times 5. Okay, let's try it for the next one. 2 over 5. I need to multiply by the reciprocal. The reciprocal of 2/15 is 15 over 2. Okay, so I've got my 2 here, I've got my 5 here, 2 here, And 15, I'm just going to go ahead and rewrite it as 5 times 3. Cross, 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 cross. Oh, and I'm left with like 3 in the numerator, but like nothing in the denominator. Whenever you're left with nothing in the denominator, there is assumed to be a 1 just hanging out there. Okay, same thing with the numerator. When everything crosses out, you always leave a 1 behind. But when it's something over 1, that is the same thing as just the whole number. Because remember, anything divided by 1 is just itself. Okay. Okay, be careful with the problems like this. This one is kind of meant to trick you. It's meant to make you think that you can start crossing stuff out. But you can't, because first you have to write 9/10 times 9/10. Okay, you have to multiply by the reciprocal. So then I got 9 times 9 over 10 times 10. Well, I know that 9 only has a bunch of 3's in it, right? And I know that 10 only has a 2 and a 5 in it. So I don't even need to worry about trying to simplify this right now. Nothing's going to cross out. So I can just go ahead and write this as 9 times 9, which is 81, and 10 times 10, which is 100. Okay, so remember, you can't start crossing stuff out. Don't get excited and start crossing stuff out until after you've flipped the second fraction. So I need to rewrite this as 4 over 5 times 5 over 1. Okay. So now I can cross some stuff out. So one thing I recommend doing is once you do this times is just be like longer line dot dot. You could just do that. You don't have to write the steps the whole time. And then I can be like boom, boom, crossed it out. Then I got a 4 over 1, which is just a 4. Now, you might wonder why I keep writing the over 1, like 4 over 1. Why don't I just write 4? I like to write the over 1 step, at least when I first start showing students fractions, because they forget a lot when everything crosses out, that it just ends up being 4. Or they'll like if the answer would have been 1/4, they'll just write 4. So it gets really confusing. So I recommend getting used to leaving that 1 behind, remembering what happens when there's just a 1 in the numerator, when there's just a 1 in the denominator, so you don't forget and make mistakes. Once you get real good at it, that's when you can start kind of cutting corners, okay? So try not to cut any corners until you feel real good at it. Okay, so 20 over 9 times, all right, let's flip this frac. Okay, so I get 3 over 10, so 20 is 2 times 10, right? 3, I'm just going to leave that alone because it's a prime number. 9 is 3 times 3, and 10, I'm not even going to do anything with that because I can already go boom, 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 boom. 2 over 3. Okay, how many more do we have? I'll do these and then I'll call it a night. So 7 divided by 21 over 2. So remember, just like with the multiplication, you want to write this as like over 1. Okay, so you want to write that as 7 over 1. Why did I make that so long? 7 over 1. I did it again. I made it super long. I made the little cross on the 7 super long. Whatever. Times 2 over 21. Okay. So I've got a 7 times a 2 in the top. And I don't need to write that 1 here. But I do need to break that 21 up. That 21 is 7 times 3. There's a lot of 2/3 answers in this this packet. It's the most popular fraction. Okay, at least in my mind, I guess. And I'm the person who made this packet, so it'll be the most popular to me. So this is going to be 15 over 16 times something. Now, to find the reciprocal, remember 3 is like the same thing as 3 over 1, so the reciprocal of that is 1/3. Okay, 16 is just a bunch of 2's. It's 4 of them, 4 2's. But 15 is 3 times 5, so I don't need to worry about breaking that 16 up. There's nothing in there that's going to cross out with anybody. Okay, so, but this 3 will, with that one. Cool. That's it. Maybe I will delete this, because I'm sure I show it somewhere. Or I can just, you know what, I'll just do it right now. So I want to show just how to, get this answer. Okay, how do I get this answer? Let's do this one here. How do I get that as an answer when I use one of these kind of calculators? Now, not all the calculators are going to work this way, but if you have a Texas Instrument one that is a scientific calculator or higher, it will give you a fractional answer. So you see here, I got like all these decimal answers, but maybe I want a fraction answer. So if I want to get 20 over 9 divided by 10 over 3, what you do is put each fraction in parentheses, okay? So you do 20 divided by 9. Okay, so that's the first fraction. Let me clear everything out. So I put the first fraction in, make sure I put it in parentheses. And now it's divided by 10 over 3. So let's do the division, and now put the second one in parentheses. Okay, so you get that, and then, like, that is not helpful, right? Okay, 0.666, repeating, like, maybe you know that's 2/3, but you don't want that answer. You want a fraction answer. So the way you can get this as a fraction answer is you go to Math, and then see this first thing, arrow fraction, that means convert to fraction, so you enter 2/3, voila. Okay, so the big thing is when you're working with fractions, make sure you put them in parentheses, and then math to fraction will give you the fraction answer. Now, if you're taking a class and you're learning how to do this, don't just always rely on the fraction, on the calculator, okay? Learn how to do it by hand, because odds are your teacher is going to want you to show work, and if you just write the answer, they're going to be like, you use your calculator, that's not what I want to see you do the steps, okay? All right, well, that is it for tonight. Tomorrow I will talk about multiples and least common multiples. So just like how I had to talk about factors and all of that, I'm going to have to do some more stuff with factors, and it's because we need to use this stuff to be able to add and subtract them. So notice we did multiplication and division first, before addition and subtraction. That's because addition and subtraction is a little harder, but don't worry, we'll do that next time, and we'll get through it. So thank you so much. Have a good week.